Hi, we are going to go ahead and look at calculating the average rate of change with an exponential graph. So we want to find the average rate of change for this graph between x equals -1 and x equals 0. So if you recall, the average rate of change is found by using the slope formula. Now, they call it an average rate of change instead of the slope because slope is constant, but when you're speaking about exponential or log functions or parabolas, quadratics, those are going to change depending on what 2 points you pick. So here we are looking at where x is -1, which is right here, and you can see the y coordinate is 4. And then here we are also looking at where x is 0, and you can see that the y coordinate is 1. So we are going to go ahead and use those 2 points to find our x1 and our y1. So when we find the slope, we have to have the 2 points, and we label the points. So x1, which we would just label our first point 1 and our second point 2. And the x part of that will be x1 and the y part will be y1. The second one, the first part, which is your first number as your x term, is x2, and your second one is y2. Now we're going to go ahead and take that and we are going to plug it into the slope formula. So the slope formula here is m equals y2 minus y1 over x2 minus x1. So let's go ahead and plug in our y2 and our y1 and our x2 and our x1. And you can see here we're going to go ahead and we have 1 minus 4 over 0 minus -1. That gives us -3 over 1. So the average rate of change between -1 and 0 is -3. Let's look at one other problem. So we're going to calculate the average rate of change, this time between 0 and 2 for this exponential graph. So we find where x is 0, and we go up, and the y coordinate at that point is 2. And where x is 2, we go up, and we see the y coordinate this time is 9. So again, we need to pick those 2 points and label our x and our x1, y1, and x2 and y2. So we have 0 and 2 is the first point, 2 and 9 is the second. As we did before, we're going to use that slope formula, y2 minus y1 over x2 minus x1. We're going to go ahead and plug them in. And you can see that y2 minus y1, which was 9 minus 2. And then we have x2 minus x1, which is 2 minus 0, equals 7 halves. That doesn't reduce any lower than 7 halves, so we'll leave it as 7 over 2 as the average rate of change.